Hi everyone, my name is Tianming. I'm from the College of Computer Science and Technology in Jilin University. Today I will present our work, GUIGAN, a deep learning-based model for learning to generate GUI designs with generative adversarial networks. Graphical user interface is ubiquitous in almost all modern desktop software, mobile applications, and online websites. GUI design is difficult and time-consuming even for professional GUI designers, and not mentioned to the software developers who had to perform many app GUI design tasks, but without sufficient professional UI design training. Developers are very likely to search existing GUI designs as a reference, but there are limitations of GUI search method. The retrieved GUI may not satisfy the developer's requirements and may be adopted by other developers, resulting in the high similarity to other apps. And developers have to keep track of the latest trend of the GUI design style, and all of this makes designers and developers have to take much more working load. So we are proposing an automated method for GUI design generation to elevate their burden. The method of generative adversarial network is introduced in this work, but the limitation of the traditional pixel-level GAN method is poor quality and diversity of the synthetic samples, especially with insufficient training data. However, GUI is composed of a site-detailed components like button, text, image, and a good GUI design is concerned more with the composition of these components rather than the fine-grained component pixels. So we pay more attention on reusing the components of an existing GUI rather than the entire GUI image. Through the research and observation of GUI data, we decompose a GUI into several components, and they are further used as a basic unit for generating new GUI design. And inspired by the natural language generation, like selecting a list of words for composing one sentence, we formulate our task as selecting a list of existing GUI components to compose new designs, rather than training the network to generate synthetic GUI image from noise. To obtain these candidate subtrees, we first crop them from the original screenshots based on the metadata. Then they are used for generating the model, for learning the model to produce a new sequence with elements st from different GUIs. Our model is developed based on the ICQ GAN, which consists of a LSTM generator and a CNN discriminator. In order to train the model to learn the features from the real-world GUI, including the GUI design style and the GUI structure, we add two corrections in training of the generator. We use loss C for modeling the compatibility of the subtrees in a generated GUI design, in which the homogeneity is applied as a criterion. And we use loss S for modeling the structure of the subtrees by evaluating the structural similarities between the generated samples and the real samples. And then the generator can be optimized by minimizing the multi-loss. Our data comes from Rico, an open-source mobile app dataset. We manually remove some disturbing GUIs such as large pop windows, advertisements, web pages, loading pages, and GUIs from game apps. And we set our experiments in two specific usage scenarios and build the first category GUI dataset, since each kind of app category owns its unique characteristics, and the second company GUI dataset because the GUI designed by the big companies are often used as references by the designers and developers when developing their own GUI. In the automated evaluation, WGAN GP and the face-off are introduced as baselines, and we get two derivation models, GUIGAN style and GUIGAN structure, from our mode by changing the multi-loss as two actual baselines. As we can see, our model achieves the best performance on feed and 1NNA, and it was a big improvement compared with baselines. It can be seen that the Symbols from our model have a comfortable appearance and a reasonable structure composed of different components. Meanwhile, it also keeps the overall harmonious design style with diversity, which can provide developers and designers with different candidates for their GUI design work. Here are examples of the same components reused in different generated symbols. And with only modeling the design style, GUIGAN style can generate GUI design with harmonious color combinations, but without very good structural designs. For example, the menu bar appears in the middle of the GUI and the login button appears at the top position. Similar issues also apply to GUIGAN structure with reasonable and diverse layouts, but terrible schema as we can see in the examples. And further, we conduct a pilot user study. We define 3 metrics design, including design aesthetics, color harmony, and the structure rationality for the human evaluation. We recruit 5 participants to rate symbols from different methods in 5-point Likert scale. We further ask participants to manually check if the component distribution of the generated GUIs is functionally correct. And our model outperforms the baseline in overall all metrics, which indicates the usefulness and the generalization of the proposed model. And we can also convert designer or developer's partial design to the full one, where our models leveraging the pre-built GUI component or control, although it can be further improved in the future work. And here's the summary. It is the first study that attempts to automatically generate the mobile app GUI design, which requires much creativity and visual understanding. And we propose a normal deep learning-based method to generate GUI designs composed of subtree sequences from existing GUI designs without additional manual presets. The experiments show that our method can successfully capture GUI design styles and structural features and automatically generate a new composite GUI composed to the aesthetic of the customers and standard GUI structure. The source code, experimental data, and the results are all released. And finally, thank you for being a part of this presentation.
Hello again. The second paper of this session is GUIGAN, Learning to Generate Graphical User Interface Design Using Generative Adversarial Networks. The author is Tianming Zhao, that is here to answer any questions that you would like to ask. So please use the chat to express your questions. So the first question from the attendees is how to perform inference. What is the input?
Yes. The input actually is subtrees, as in the paper. They are treated as words, like in NLP-like tasks with the embedding. And compared with natural language, images, especially GUI images, are more regular with many straight lines and clear text. Our method focuses on the reusing of the previous design components. So we first define and get the design components as subtrees. And these subtrees from existing GUIs are taken as a basic unit for composing new GUI design rather than the pixels.
Okay. The next question is in what sense the new graphical user interface may be affected by the cultural background of the graphical user interfaces used to learn. Maybe the proposed graphical user interface is not the same if we change the set of graphical user interfaces used in the learning process.
I see some human intervention is actually needed, but in our method, the model is full automatic to learn how to generate the symbols.
Okay, we have another question from the attendees. Are the subtrees static, or can the model edit the individual subtree elements to create more unique designs?
Okay. The subtrees are from the existing GUIs, and they are they cannot be edited. And we use the existing GUIs. It's kind of face off. We're directly using them as a basic unit. The model learns to generate the symbols from these candidate subtrees and select them to recomposing a new one.
Okay, another question is about the conflicts. How do you manage possible conflicts? For example, imagine that for some widgets, there are two possible designs. And is it possible the human intervention in case there are some kind of conflicts?
There can be conflicts, but in our symbols, because the subtrees have a large numbers, the conflicts situation is very rare. So I cannot see the conflict is very usually happen.
Okay. And my last question is about your future steps in this research. I mean, how do you plan to improve this proposal in the next future?
Yes, in the future, I think there will be more information can be used for modeling, and it's up to the specific task or a scenario. We can summarize a list of issues of the current model by carrying out a detailed analysis of the category generation of current data. Also, add a list of rules to post-process generated GUIs, like menu bar should be on the top of the GUI and so on. And our model can be used to convert designers or developers' partial design to full one. And the part that our model can be used to do this job, but it's very simple. We just extend the star tokens from one star subtrees to 2 or 3 star trees, and we see what we got. So in the future, we plan to further improve these functions. Yes.
Okay, so if there are no more questions from the attendees, we can finish here the question and answers session for this paper. So receive a virtual clap for all the attendees. Very nice work. And we see you again in the next paper, okay? So see you.
Thank you.